Hi everyone, Mr. Lenny here from Impact Circle, and today we will talk about map scales. Map scales can be written in a number of different formats. The most common format is in ratio form, which will look something like this. One is to 100,000. This means that 1 cm on the map will represent a distance of 100,000 cm in real life. You have to note that when the scale is given, there are no units involved. This means that the units will be the same on the left as well as on the right. That's why if the left is cm, the right must be in cm. If the left is meters, the right must also be in meters, and so on. If you wish to convert to different units, you can, but you have to make it clear as you present your answer. So 1 cm representing 100,000 cm is also the same as 1 cm representing 1,000 meters, or 1 cm representing 1 km. You have to make the units clear if the units are different. This scale can also be written in the form of a fraction. For example, 1 over 100,000. And this format is actually called the representative fraction. So if the question asks you for the representative fraction, please give your scale in a fraction format like this. But it actually means the same thing. Right, let's explore a few different scales. Let's say you have a scale of 1 is to 50,000. What does this mean? This means that 1 cm on the map represents 50,000 cm in real life. If we convert this, it will be 1 cm on the map representing 500 meters, or 1 cm on the map representing half a kilometer. So the question often goes like this. If the road in real life is 10 kilometers, how long will the road be on the map? So using this conversion, we can actually find the answer. Since 1 cm on the map represents 0.5 km in real life, and we want to find out what 10 kilometers in real life is on the map, we just write it in this format, and we can actually use the normal ratio or proportionality method, okay, to solve this. So we take 10, divide by 0.5, multiplied by 1 in an L shape. So like this, you divide and then you multiply. You divide and then you multiply, right? Very similar if you would have a double arrow. For example, sometimes you actually present this way. Sometimes it goes like this. 1 cm represents 0.5 km. And let's say you want to find out 10 km. You write it here. And again, you go with the L shape. 10 divided by 0.5 times 1, which will give you 20 cm. So the road that is actually 10 kilometers will be represented by a line that is 20 cm long on the map. Let's do one more example regarding area. So it's very important to know that for area, the scale is different from the distance scale. And we need to do some conversion. If we are given the distance scale and what we want to solve problems involving area, we need to convert the distance scale into a area scale. And the way to do this is to square both sides. So let's take a look at this example. Under 1.4.3, it says the scale of a map is 1:50,000. 1:50,000. Find the area of a lake in real life if the area of the lake on the map is 12 cm squared. Give your answer in square kilometers. So before we do anything, it is very important, since we are converting from cm to km or cm squared to km squared, we need to change this scale into one that has both cm as well as km. So first, we put 1 cm represents 50,000 cm. Then 1 cm represents 500 meters. And then 1 cm represents 0.5 kilometers. If you can jump straight from here to here, then go ahead. It's not a problem, right? But don't make any mistakes. Once you have expressed the relationship of the cm on the map with the km in real life, then we can create the area scale by squaring both sides. So we'll have 1 squared cm squared is to 0.5 squared km squared. Okay, and this will give us 1 square cm representing 0.25 square kilometers, or 1/4 of a square kilometer. As you can see, the ratio for the area is very different from the ratio of the distance. So please never ever assume that they are the same. That is a very common mistake. Once we have this area ratio or area scale, we can actually answer the question. The question wants the area of a lake in real life if the area of the lake on the map is 12 cm squared. So the question is 12 cm squared on the left or on the right? It's 12 cm squared, right? It's on the map, right? Normally, the values on the map are on the left, and the values in real life are written on the right, right? So just make sure that you put it in the right column, right? So 12 cm squared is here, and you want to find this. So you take 12 divided by 1 and multiplied by 0.25. 12 divided by 1 multiplied by 0.25 will give us 3 square kilometers. So we have just found out that the area of the lake in real life is 3 square kilometers. Another way you can look at it is this. On the left, to get from 1 cm squared to 12 cm squared, you actually have to multiply by 12. And because this is direct proportion, right? If we multiply by 12 on the left, we also have to multiply by 12 on the right. And so 0.25 multiplied by 12 gives us 3 square kilometers. And we will also get an answer. The area of the lake in real life is 3 square kilometers. So there you have it. Please be careful. Remember that the scale for the area is different from the scale of the distance. If you want to get from distance scale to area scale, you have to square both sides. And if you want to get from the area scale back to the distance scale, you have to do the opposite. You have to square root both sides. Please bear this in mind, right? Area is 2-dimensional. Distance is 1-dimensional, right? To get from 1 dimensions to 2 dimensions, you have to square it. But to get from 2 dimensions back to 1 dimensions, you have to square root it, right? So this is the most important thing you must know. And with that, that's all for today's lesson. Thank you very much.